Okay, so hello to everyone. We're recording this session. As you can see, the Open PLC is now working. Okay, so the problem I ran into is the installer would not install properly. As you could see, there was a fault in the Python execution. Apparently, the 2022 version is not compatible with the 2024 version. So you have to basically uninstall the whole unit, the whole software package, and then reinstall a fresh one and then update that. Okay. So for today, we work on um, level sensing for um, PLCs. So we'll create a new file under documents under Arduino PLC. We'll create a new folder. That folder will be called level sensing. Okay. So again, we'll be using the ladder programming language. So for this one, we'll have to do some adjustments. Okay. What do I mean some adjustments? Okay, we'll have to employ some adjustments. We need to use an analog input rather than digital output. Okay. So to cover this one, we need again to go back to autonomy, Open PLC, physical address. So the physical addressing required is something that we have to make sure that we can uh, obtain, and we can basically utilize properly. So not working on that one. There we have it. Okay, so again, we're using Uno as a base platform. And as you can see here, in this version of the pinouts, the value for the analog inputs that we have is called IW, or input word. Okay. While the value for the outputs is called QW. Okay. So QW only goes up to 2, IW only goes up to 5. Okay. Pero in fairness, the processor only has one analog to digital converter. These are just multiplexed. So with that in mind, we can try to go back to the PLC program. Okay. So here, I now need to say analog 1. Okay. So for this word type, I'll use the integer. So no issue of changing the value anymore. Sometimes we would also use unsigned integer. Pwede rin naman siya. And here we would assign a value of IW 0.0. Okay. So this is the lower sensor natin. Okay. The other one, analog 2, is 0.1, which is the upper sensor natin. Okay. So basically, I did not opt to use a switch or 2 switches, but instead I used a analog sensor to detect the distance. Okay. So if that would be the case for the lower and upper sensors that we have, we also need to have a motor output. So for this one, we no longer have the analog 3, but we have the digital 13 pin. And we need to change this one to Boolean. And we need to change this one to QX because that is the designation for digital output. Okay. So that we can hit the value of, so this is for the motor. Motor at D1, 3. Upper sensor at A2, sorry, A1, A0. Okay. So what else do we need? We need a starter system. Okay. So the starter system is just a switch that's connected to D2. Start switch. IX for an input boolean value. Start. So this is push button at D2. So that's about it for this one. Okay. So let's write down the variables. Okay. So we need some expressions for our comparison purpose. Let's say I have a value of 500 here. So this is a numerical value, okay? So 500 siya. And I have another value of 200 or 50 as my minimum. So 500 is my maximum and 50 is my minimum. I now have to specifically give a um, variable source. Okay. So the variable source would be analog 1, and we would pair that up with the lower side because this is the lower sensor. Okay. So the other one, variable for the other side is this analog 2. Okay. So next we would make a functional block. The functional block again has to adhere to the general standard blocks. Okay. Standard blocks, I think, won't cut it because there's no comparison here. We only have a value of specific towards a comparison method. Okay. So for analog 2, if this is greater than 500, we should get a response greater than or equal to. So sometimes kasi lalampas yung value. Sometimes the values would exceed the limits. So that's why we use greater than or equal to rather than the other side. Okay. So I would add another functional block here. I would go to comparison, and I would go to less than or equal to. Okay. So if it is less than or equal to 50, we would do a specific something. Then we go back to the standard blocks and we go into this one. Okay. So we have two types of RS flip-flop. We have the one which is set dominated, which means priority is given towards the set value. Okay. So if it's always less than a specific, or if the value of S1 is primed or set to 1, it's irregardless whether the reset is actually on or off. It's dominated by the set value. Okay. For this one, we'll do the opposite. We'll do the reset dominated one. So, okay. So we get this item here. The reset action to stop the motor from operating is initialized by the value going equal to or above 500. Okay. So we can put that one there. Okay. For the other side, we just sequence it towards the less than or equal to. And then we add the motor, which is motor. And we add the start switch. Okay. So again, the start switch for our purpose should be negated kasi this is, again, zero primed. Hindi siya 1 yung ginagamit natin to start the system up if you're using a push button. So next, we need to terminate the system. So write power rate is what we need for this one. So this is basically the setup. Okay. Technically, you can have one analog sensor sa totoo lang. Let's start to play with that idea instead of using two. Okay. So you have a single analog sensor that has the data, sensor data, instead of having two. Kasi economies of scale is cheaper to scale one system up. Okay. So we'll maintain muna analog 2 in case we need it. So let's go into motor, start switch, analog 1 value here. And then we'll go into our conditions for the SR, which is S, R, and Q. Okay. So notice the GE and the LE is not reflected within the type parameters that we have. Okay. Sinalabas. Okay, so that's why we need to put in the S and the R inputs together with the Q so that we can understand what state this thing is actually on. Okay. Analog 1 is there. Okay. So we can save the file and then we can choose run. So you can see it's kind of computing. Okay. So in this case, the motor is setup is true, okay, because of this closed, okay, system that we have here. Therefore, we also need to, I think, negate this one para off siya initially. Okay, so that's it's off initially. Okay, so when the value is false, when the value is true, doesn't matter what state this one is. Okay, the motor is going to kind of work properly. Okay. So when this is false, this one will actually have an output as well. Okay. So in this case, because the analog output is 0, it's less than 50. Okay. Let's change this one. Let's change it to uh, 100. Let's say the level went up already. You can see that the SR flip-flop is still set to true. Okay, so therefore, if this is set to a value which is equal to true, we have a motor still working. Okay, so if we set the analog value to something like 200, it's still on. If we set the value to 500, okay, what happens here? You get a false uh, setup here. Okay, but as you can see here, your start is still somewhat on. Okay, naka-on pa rin siya. So, therefore, you have a problem. This is a logical problem now. Okay. So that means that we have an issue with the way that the start switch is actually set up. Okay. Let's just use the motor directly. Let's ignore this one for in the meantime. Okay. So let's try it out again. So if the analog value is okay, because it's negated, sorry. I have to put this back to normal once more. So if you're starting at from 0, you're still on the true value. If you went to 100, you're still true. The motor is still on. If you went to 250, the motor is still on. But once you arrive at 500, the motor should be off in this case. So here, ano yung problem? The problem lies with the way that we sequence the start. So apparently it doesn't work if it's there at the end of Q. Okay. So where do you set it up? You set it up here towards R1 natin. So you make a bypass, kumbaga. So if this one is closed or open, sorry. Let's put it to an unnegated value. Okay, normal lang siya. So if you have a system which is basically turn on, okay. Ang problem lang nito, you have a wire here that sometimes cannot be crossed. Okay. So what's the issue? The issue is something that pertains to logic values. having a wire connected directly to this one might short out the value. Okay. So sometimes it's not a good idea. So what we need to do is we need to use a logical gate or functional block. Okay. So we'll use a OR block here. So meaning to say that the reset function is now either dominated or manipulated by the out from GE or greater than or equal to, or something which is operated by the start switch. Okay. So here we need another left rail in order to accommodate the start switch. Okay. So once we run that one, okay. So once you set this one to true, your motor stops working. So it doesn't matter if this one is a value which is higher, analog one. Okay. So lower pala, 20. It will not turn on. Okay. Doesn't turn on. Kasi the start switch is the one calling the shot. So if we toggle the value and put it to false, you can see the motor turns on. So that in turn is our start switch position. Cannot be placed here for all obvious reasons that it will force the motor to turn on, turn off, regardless whether the Q value is actually the same or not. So it's just better to put it there dun sa kabilang side. With this one, we can confirm that analog 2 is no longer needed. We can stop first the simulation and then remove analog 2. Okay. So you can just use a single analog sensor to do the job for you. Tapos you get the best possible solution out of it. So yan lang yun, level sensor natin. Okay. So whether you're using a DC motor and AC motor, it doesn't really matter too much as long as it's a pump. Wala siyang issue. Okay. But for our purpose, since we've installed the larger pumps in the lab, yung pumps for the wipers. So we're bound with DC motor for this one. Okay. So level sensing and motors to be exact for this item that we have here. Now it's far more simpler for level switches or float switches. Kasi what you will need to do is you will need to just have a switch connected to a few of the inputs natin, and that would be your level switch function. Okay. So that's it for level sensing. Okay. So we'll save this one out. Okay. So as a example for level sensing, and you can test the logic pattern out in your laboratory this coming Saturday. Okay. Thank you very much for watching. I'll see you all on Saturday.